Assalamualaikum and a very good day to all. My name is Nurjan Ahmad Faizal and I am here to present my group assignment for computer architecture, which is entitled Demonstrating the Technologies of Ethernet Communications and Input Peripherals in a Computer System. My group consists of 3 persons, which is Tan Guan Seng, me, myself, and Nur Najha. First of all, I will start off with a brief explanation regarding Raspberry Pi, which I believe is very common to all of us nowadays. It is a small computer that acts as a powerhouse of computers or hardware prototyping tool that drives HDMI displays, process mouse, keyboard, camera inputs, and such by connecting them to the internet and running full-featured Linux distributions. They have bidirectional input-output pins that can run LEDs, pin motors, and also read button presses. There are several types of Raspberry Pi, but the mains are A, B, and 0. The primary Raspberry Pi was 1B, which was released in April 2012, and by the following years, the recent one is Raspberry Pi 4, which was announced in 2019. There are two sizes, which is considered as standard and compact, and all of these Raspberry Pis are equipped with Ethernet except for A, A+, and 0, while the wireless ones start from only 0 generation onwards. However, these Raspberry Pis are not all that is applicable for USB resource booting mode, which uses flash drive. The only ones that are applicable are Raspberry Pi 2B, V1.2, 3A+, 3B, and 3B+. So moving on to the next slide is GPIO, General Purpose Input Output. It is a basic interface on microcontrollers that turns on and off devices. It allows the connection of other electronic components and modules through the input-output pins and is used in wide ranges of purposes, such as communicating with other circuitry like extension boards and custom circuits. There are two types, which is 26 pins and 40 pins. The ones with 26 pins are usually the earlier versions, which is 1A and 1B, but however it is already discontinued for now, and to run these pins, software configurations and programming languages are required, such as Python or C, which uses wiring Pi library. The next one is the GPIO pinout. The left one is 26 pins and right one is 40 pins. This is the detailed reference of pinout diagram. As we can see, it is not only focused on the standard pins but also reference for 12C, SPI, and UART. The 12C is a inter-integrated circuit pins that connect and communicate with hardware modules supporting this protocol, which usually uses around 2 pins, and the SPI is the serial peripheral interface, is somewhat like 12C but with different protocol, while the UART is the universal asynchronous receiver transmitter serial pins that communicates with other devices. If you can see on pins 27 and 28, there's DNC, which is do not connect, and there's two other pins, which is power pins that pulls power directly from the Raspberry Pi, and GND, which is normal ground pins. Okay, this is the explanation I just mentioned just now, and we'll move on to the Raspberry Pi 3B architecture, which we will focus on because we will use Raspberry Pi 3B in this assignment. This is how it looks like, and the architecture basically consists of 4 USB 2.0 cores in CPU via onboard 5-port USB hub. The CPU usually is 1.2 GHz 64-bit quad-core ARM Cortex-A53 processor, which is said to be 10 times the performance of Raspberry Pi 1 and 80% faster than Raspberry Pi 2. The GPU is based on Broadcom Video Core 4 with the clock frequency of range 300 to 400 MHz and memory of 1 GB, which shares with the GPU. So, the normal ones usually use only 250 MHz frequency range, clock range, and the Raspberry Pi 3B have a Wi-Fi and Bluetooth module that is power regulated correctly. It is basically the most powerful and ideal for retro gaming emulation or code debuggs, and it can be set as same size as Raspberry Pi 2 but with slight changes in component placement such as mentioned for addition of Wi-Fi and Bluetooth SoC system on chip on the Raspberry Pi. So moving on to the next slide is Raspberry Pi 3 GPIO pinouts. It's just the same as the ones I explained in the general pinouts. And going on with the procedures, which is part A, Raspberry Pi simulation installation setup, where we are supposed to download virtualization software, VirtualBox, and Raspbian OS to run the pixel.iso and choose as shown in the picture, and then we will rename it as Raspbian OS, just as shown, and load the Raspbian virtual image in the VirtualBox with the following parameters as shown, create and start. Next one, we will set up the mouse and keyboard by choosing the language, and the function of Oracle VirtualBox is to make sure we run the Raspbian in dual OS situation, which are Windows and Raspbian OS. Next one is setting up the GPIO emulator in the terminal. The command shown in the terminal is to unzip the iot4smes.zip in the Raspbian OS. Hence, we will have the Raspbian environment in our desktop. Okay, next part is part B, which is routing Raspberry Pi hardware. In normal operations, the OS will be in charge and GPU will drive the display, while in booting operations, it will play another role. So when the board is powered up, the booting begins and GPU will turn on, while the ARM cores will remain off, and GPU will then execute the first stage, reading the SD or micro SD card, and loads the bootcode.bin, which is the second stage, bootloader, into the L2 cache. And then the bootcode.bin will turn on the SD-RAM, which is the separate memory chip on SoC, and loads the third stage, loader.bin. The loader.bin will then read the start.elf, the GPU firmware, and start.elf will read the config.txt, cmd line text, and kernel.img. Finally, it will start the OS Linux base as Raspbian, and once the Linux has booted, the boot partition is mounted as /boot. This last part is a binary blobs firmware that are loaded on the video core in the SoC, which then will take over the boot process. This is basically just how I mentioned just now, but however, in Raspberry Pi, it will not bootcode.bin will not be used because it has been replaced by bootcode in the onboard EEPROM itself. So for the next part, C, D, E, and F will be explained by my group mates, which is Najiha and Tan Guan Sang. Thank you.
Hello everybody. What is virtual memory statistic? Virtual memory statistic is the process of reporting the information about process, memory, board input-output, paging, and CPU activity. We can see in the picture written of VMstat34. VMstat is the tool to read the virtual memory statistic. Delay in 3 seconds, executing 4 interval. We can see the process RB is a number of unit running, memory inside, block read and written, system, and CPU. Next is programming GPIO. Before we do a programming, we need to update the Raspbian. Because of I am using Debian system, I need to type command sudo apt-get update. After I completely update, I am able to upgrade the Raspbian. It's very essential to upgrade because to ensure it's compatible in Python. Next, after I done update and upgrade, I must, and very crucial, to install the library of GPIO. It is a tool to ensure the system able to read and understand the coding information. Otherwise, your coding will turn to error or not able to read. Before we build the circuit, we must understand and know which pin we need to use. So, by using the command GPIO read all, we able to know the pin number, GPIO number, the name of pin, and the mode of pin. So, it's a very crucial to ensure the circuit is put correctly, so our system, our circuit will working functionally. Thank you.
Hi, I'm Guan Xing. So actually at this moment I present the section E, which is to build a simple circuit. So this figure actually shows the Python coding to build a simple circuit actually. So for the next slide, this slide actually show the GPIO emulator after we type the Python coding in the Python program. Well, for this slide, I will explain the three different situations. So the first situation is when the GPIO 15 is pressed, the result is shown as below. We divide the result parts into two aspects, which is the output pin and also input pin. So for the output pin, the GPIO 4, GPIO 17, 18, and 21 return to origin with output 1. However, in the other hand, the input pin GPIO 23, 24, and 26 is remain unchanged. For the next situations, when the GPIO 23 is pressed, the result is shown as below. The output pin GPIO 4, 17, 18, and 21 returns origin with output 1. In input pin, which consists of GPIO 15, 24, 26, is remain unchanged. So this is a different situation. When the GPIO 24 is pressed, the result is shown as below. The output pin GPIO 4 and 17 returns to origin with output equal to 1. And the difference is that when the output pin GPIO 18 and 21 returns green color with output equal to 0. In the situation, the input pin which consists of GPIO 15, 23, and 26 is remain unchanged. Next, I will explain the section F, which consists of the Wi-Fi on the Raspberry Pi. So the coding above actually show we try to display the configurations of the wired Ethernet port without Raspberry Pi. Actually, we type the coding in the terminal windows in the Raspberry OS, and this is the result we get. Well, so for this part, I present to you for the frequently asked question, which is the FAQ. So firstly, to create a directory, should we use the mkdir command? Second, you can confirm the command did indeed set the directory to the home directory using the pwd command. Thirdly, the apt command can be used to keep the software up to date. Is it correct? To create or edit test film to the edited nano included with Raspbian can be used. Is that correct? Fifth, the cp command is followed first by the file to copy and then by the name to be given to the new file. Is that correct? Lastly, thank you for watching our presentation. Thank you very much.